topic motion. First one, an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. Solution. Yes, an object moving a certain distance can have zero total displacement. Displacement refers to the shortest distance between the initial and the final position of the object. Even if an object moves through a considerable distance, if it eventually comes back to its initial position, the corresponding displacement of the object would be zero. Second one, a farmer moves along the boundaries of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? Solution. Given that the farmer covers the entire boundary of the square field is 40 seconds, the total distance travelled by the farmer in 40 seconds is 4 into 10, that is 40 meters. Therefore, the average distance covered by the farmer in 1 second is 40 meter divided by 40, that is equal to 1 meter. 2 minutes and 20 seconds can be written as 140 seconds. The total distance travelled by the farmer in this time frame is 1 minute into 140, that is equal to 140 minute. Since the farmer is moving along the boundary of the square field, the total number of laps completed by the farmer will be 140 meter divided by 40, that is 3.5 laps. Now the total displacement of the farmer depends on the initial position. If the initial position of the farmer is at one corner of the field, the terminal position would be at the opposite corner. Since the field is square, in this case the total displacement of the farmer will be equal to the length of the diagonal line across the opposite corners of the square. Applying the Pythagoras theorem, the length of the diagonal can be obtained as follows. Square root of 10 square plus 10 square, that is equal to square root of 200, that is equal to 14.14 meter. This is the maximum possible displacement of the farmer. If the initial position of the farmer is at the midpoint between two adjacent corners of the square, the net displacement of the farmer would be equal to the side of the square, which is 10 meter. This is the minimum displacement. If the farmer starts at a random point around the perimeter of the square, his net displacement after traveling 140 meter will lie between 10 meter and 14.14 meter. Third one, which of the following is true for displacement? It cannot be zero. Its magnitude is greater than the distance traveled by the obtained solution. Further of the statements are true. Statements A is false because the displacement of an object which travels a certain distance and comes back to its initial position is 0. Statement 2 is false because the displacement of an object can be equal to but never greater than the distance traveled. Second one, distinguish between speed and velocity. Differences between speed and velocity. Velocity, speed. Velocity, it refers to the displacement of a given object over a time interval. It refers to the distance moved by an object over a time interval. It has a specific direction. It does not have any direction. Velocity is equal to displacement divided by time. Speed is equal to distance divided by time. Velocity can hold a negative value. Speed cannot hold a negative value. Under what conditions is the magnitude of average velocity of an object equal to its speed? Solution. Since average speed is the total distance travelled in a time frame and velocity is the total displacement in the time frame, the magnitude of average velocity and the average speed will be the same when the total distance travelled is equal to the displacement. Third one, what does the odometer of an automobile measures? Solution. The odometer measures the total distance travelled by the automobile. Fourth one, what does the path of an object look like when it is in uniform motion? Solution, the path of an object in uniform motion is a straight line. Fifth one, during an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, that is 3 into 10 to the power of 8 meter per second. Solution, given that the signal travels in a straight line, the distance between the spaceships and the ground station is equal to the total distance traveled by the signal, that is 5 minutes is equal to 5 into 60 seconds, that is 300 seconds. Speed of the signal is equal to 3 into 10 to the power of 8 meter per second. Therefore, total distance is equal to 3 into 10 to the power of 8 meter per second into 300 second, that is equal to 9 into 10 to the power of 10 meters. Question 3. What will you say a body is in uniform acceleration, non-uniform acceleration? Solution, uniform acceleration. In this type of acceleration, the body moves along a straight line and its velocity increases or decreases at a uniform rate. It changes at a constant rate in any constant time interval. Non-uniform acceleration. In this type of acceleration, the body moves along a straight line and its velocity increases or decreases at the rate that is not uniform. It changes at a different rate for a given constant time interval. Second one, a bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Solution, given the initial velocity u is equal to 80 km per hour, that is equal to 80,000 meter by 3,600 second, that is equal to 22.22 meter per second square. The final velocity v is equal to 60 km per hour, that is equal to 60,000 meter divided by 3600 second, that is equal to 16.66 meter per second. Time frame is equal to t is equal to 5 seconds. Therefore, acceleration a is equal to u v minus u divided by t, that is equal to 16.66 meter per second minus 22.22 meter per second divided by 5 second, that is equal to minus 1.112 meter per second. Therefore, the total acceleration of the bus is minus 1.112 meter per second square. It can be noted that the negative sign indicates that the velocity of the bus is decreases. Next question, a train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. Solution, given the initial velocity u of the train is equal to 0 meter per second at rest, terminal velocity v of the train is 40 km per hour, that is equal to 11.11 meter per square. Time interval t is equal to 10 minutes, that is equal to 600 seconds. The acceleration of the train is given by a is equal to v minus u divided by t, that is equal to 11.11 meter per second square second minus 0 meter per second divided by 600 second, that is equal to 0.0185 meters per second square. What is the nature of the distance time graph for uniform and non-uniform motions of an object? Solution, for uniform motion, the distance time graph is a straight line. On the other hand, the distance time graph of an object is non-uniform motion is a curve. The first graph describes uniform motion and the second one describes non-uniform motion. What can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? Solution, that this distance time graph can be plotted as follows. Since there is no change in the distance traveled by the object or the y-axis value at any point in the x-axis time, the object is at rest. What can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? Solution, This speed time graph can be plotted as follows. Since there is no change in the velocity of the object y-axis value at any point of time x-axis value, the object is said to be in motion. What is the quantity which is measured by the area occupied below the velocity time graph? Solution. Considering an object in uniform motion, its velocity time graph can be represented as follows. The area below the velocity time graph is the area of the rectangle OABC, which is given by OA into OC, but OA is the velocity of the object and OC represents time. Therefore, the shaded area can be represented as area under the velocity time graph, that is equal to velocity into time. Substituting the value of the velocity as displacement by time is in the previous equation, it is found that the area under the velocity time graph represents the total displacement of the object. A bus starting from rest moves with a uniform acceleration of 0.1 meter second square for 2 minutes. Find the speed acquired, the distance traveled. Solution. Given the bus starts from rest, therefore initial velocity u is equal to 0 meter per second, acceleration a is equal to 0.1 meter per second square, time is equal to 2 minutes, that is equal to 120 seconds. Acceleration is given by the equation a is equal to v minus u divided by t. Therefore, terminal velocity v is equal to at plus u is equal to 0.1 meter per second square into 120 second plus 0.0 meter per second square, that is equal to 12 meter per second plus 0. Meter per second. Therefore, terminal velocity v is equal to 12 meter per second. As per the third motion equation, since a is equal to 0.1 meter per second square, v is equal to 12 meter per second square, u is equal to 0 meter per second and t is equal to 120 second, the following value for s, that is distance, can be obtained as distance s is equal to v square minus u square divided by 2a, that is equal to 12 square minus 0 square divided by 2 into 0.1. Therefore, s is equal to 720 meter. The speed acquired is 12 meter per second and the total distance traveled is 720 meter. Second one, a train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. Solution. Given initial velocity u is equal to 90 km per hour, that is equal to 25 meter per second. Terminal velocity v is equal to 0 meter per second, acceleration a is equal to minus 0.5 meter per second square. As per the third motion equation, v square minus u square is equal to 2as. Therefore, distance traveled by the train s is equal to v square minus u square divided by 2a. S is equal to 0 square minus 25 square divided by 2 into minus 0.5 meter, that is equal to 625 meters. The trains must travel 625 meters at an acceleration of minus 0.5 meter per square before it reaches the rest position. Third question, a trolley while going down an inclined plane has an acceleration of 2 centimeters second square. What will be the velocity 3 seconds after the start? Then initial velocity u is equal to 0. The trolley begins from the rest position. Acceleration a is equal to 0.02 meter per second square. Time t is equal to 3 seconds. As per the first motion equation, v is equal to u plus at. Therefore, terminal velocity of the trolley v is equal to 0 plus 0.02 meter per second square into 3s, that is equal to 0.06 meter per second. Therefore, the velocity of the trolley after 3 seconds will be 6 centimeter second square. Fourth one, a racing car has a uniform acceleration of 4 meter per second square. What will it covers in 10 seconds after start? Solution. Given the car is initially at rest, initially velocity u is equal to 0 meter per second, acceleration a is equal to 4 meter per second square, time period t is equal to 10 second. As per the second motion equation, s is equal to ut plus half at square. Therefore, the total distance covered by the cover s is equal to 0 into 10 meter plus half into 4 meter per second square into 10 square, that is equal to 200 meters. Therefore, the car will cover a distance of 200 meters after 10 seconds. A stone is thrown in a vertically upward direction with a velocity of 5 meters per second. If the acceleration of the stone during its motion is 10 meters second square in the downward direction, what will be the height attained by the stone and how much time will it take to reach there? Solution. Given initial velocity u is equal to 5 meter per second, terminal velocity v is equal to 0 meter per second. Since the stone will reach a position of rest at the point of maximum height, acceleration is equal to 10 meter per second square in the direction opposite to the trajectory of the stone is equal to 10 meter per second square. As per the third motion equation, v square minus u square is equal to 2as. Therefore, the distance traveled by the stone s is equal to 0 square minus 5 square divided by 2 into 10. Distance s is equal to 1.25 meters. As per the first motion equation, v is equal to u plus at. Therefore, time taken by the stone to reach a position of rest, maximum height, that is equal to v minus u divided by a, that is equal to 0.5 by minus 10 second. Time taken is equal to 0.5 seconds. Therefore, the stone reaches a maximum height of 1.25 meters in a time frame of 0.5 seconds.